A sequence is a function whose domain is the natural numbers and whose outputs are the terms of the sequence. You can write a sequence using a recursive formula. A recursive formula is a function rule that relates each term of a sequence after the first one to the ones before it. Consider the sequence 7, 11, 15, 19, and so on. You can use the common difference of the terms of an arithmetic sequence to write a recursive formula for the sequence. For the sequence 7, 11, 15, 19, and so on, the common difference is 4. So we let n equal the term number in the sequence. So for instance, the first term would be n equals 1, the second term would be represented by n equals 2, and so on. And then we'll let a of n, notice the function notation, equal the value of the nth term of the sequence. The value of term 1 can be written as a of 1, function notation, and that equals 7. So a of 1 equals 7. The value of term 2, a of 2, will equal, and this is where it gets a little complicated, this is where we get to the recursive part of the function, it equals a of 1 plus 4, and that's 11. Notice the value of term 3, a of 3, well that equals a of 2 plus 4, our common difference, and that's 15. The value of term 4, well we can write that as a of 4, that will equal a of 3, which remember is just the term right before it in the sequence, plus 4, and that's 19. So the value of term n, any term n in the sequence, will equal a of n minus 1, so that means the term right before it, plus 4. And in the bubble, the value of the previous term, plus 4. Therefore, we've generalized to a formula, and we can state that the recursive formula for the arithmetic sequence above is a of n equals a of n minus 1 plus 4, where a of 1 equals 7. Problem 3. Writing a recursive formula. Write a recursive formula for the arithmetic sequence below. What is the value of the 8th term? Well, the sequence is 70, 77, 84, and 91. So we can pretty quickly pick out the common difference of 7. Step 1. A of 1 equals 70. That's our first term. A of 2 equals the term right before it, or a of 1, plus 7 more, that's 77. We can continue that pattern until we get to the point where we can generalize that a of n equals a of n minus 1. Remember, we can always think of that as the term right before, plus 7. So there's our formula. And above we have a of 1. So the recursive formula for the arithmetic sequence is a of n equals a of n minus 1 plus 7. Remember, that's only half of what we need to define a recursive formula. We also need to know where the sequence begins. So a of 1 equals 70. Step 2, we're asked to find the value of the 8th term. So to find the value of the 8th term, you need to extend the pattern. So a of 5, well that's going to be a of 4, the term right before it, plus 7 more. A of 6, we'd add 7. A of 7, add 7 more, till finally we get to a of 8, and we'd find that equals 119. So the value of the 8th term is 119. Your turn. Write a recursive formula for each arithmetic sequence. What is the 9th term of each sequence? And E is a reasoning item. Is a recursive formula a useful way to find the value of an arithmetic sequence? Explain.